Welcome to the video for section 9.2. This is the characteristics of a quadratic function, and in all reality we're kind of looking at the anatomy of a quadratic function. We're figuring out where, like on humans we have legs, we have a head, we have arms. Well, in a quadratic function they have various things too, a vertex, axis of symmetry, and points and that sort of thing. So we're going to go through how to find some of these without having to necessarily graph them every single time. However, we are going to make a graph and we will check our answers with our graph, and so that will hopefully help us. So let's start in on the very first thing. Here is the first little bit of anatomy that we have for a function, for a quadratic function. There are things called roots or zeros of a function. Zeros of a function, this is a x value that makes a function equal to 0. So essentially, if you put a specific x value into the equation, your outcoming y will be 0. So when it's graphed, this is where the parabola crosses the x-axis, and there can be a few options for the number of zeros we can see. We can see either none of them, 1, or 2. And so this is whether or not, if you see 0 of them, it means that the function doesn't cross the x-axis at all. If you see just 1, that means the parabola just barely touches the x-axis and goes back up, so that means that this is the vertex. And number 2, and if you see 2, that it means that the arms come up and cross in 2 places. And actually, if you were to take the average of those 2 arms, you will find what we call the axis of symmetry. And we will talk more about that later. It gives axis of symmetry. So that's all kind of important information. So zeros of a function, they give you the place where it crosses the x-axis. So what we're going to do now is we're going to actually go over here and we are going to play around with an equation. We have y is equal to x squared minus x minus 2. And what we will do with this is we are going to actually create a table of values. We've done this already. We're going to create a table of values and graph this baby. So table of values means we're going to have x and y's. So for every x I put in, I should be able to get a y out of it. And we're going to put in the numbers -2, -1, 0, 1, 2. And I'm leaving a little bit of space just in case I need to add some more values to see if I can find where the vertex is or something else, just in case. So if I put a -2 in this equation, I'm essentially doing -2 squared minus -2 minus 2, okay? So -2 squared is 4. Minus the -2, I can say plus 4 minus 2, so we get a 6. If I were to put a -1 into this equation, that is my next step. Let's see what we get out of that. So if we put -1 in here, -1 squared is a positive 1, minus a -1, so that's plus 1, minus 2. We get 2 minus 2 is equal to 0. Now, before, when we said the zeros of an equation, we said that a certain x value will get you a certain, or will get you a y value of 0, so it looks like we just found that. It's kind of cool. If we were to put in the other numbers, we should be able to get some answers out. I'm going to pause this video so I can put those in, and you're just going to magically see them appear. Okay, so they've magically appeared. Here we go. I ended up finding -1 and 2 are my zeros, and this is kind of interesting. I'm seeing an interesting pattern happen here. Usually we end up, or from what we've seen so far, is we've had just whole numbers go in and whole numbers come out, and we'll have one point where in between our zeros or something like that where the parabola comes back around. And when I see this, if I put in 0, I get out a -2, and if I put in a 1, I get out a -2. So that makes me think that that vertex, that point where everything changes, is in between those two. So let's graph this equation. We're going to graph this equation on this big old axis, or x and y axis that I've created. So let's do that. We're going to go over -2 and up 6. 1, 2, 3, 4, 5, 6. So we'll have a point right here. I'm going to go over 1 and we're at 0. I'm going to go down 0 and we get -2. Go over 1 and we get a -2. We go over 2 and we should get a 0. So it looks like my graph is something like this so far. I can always put everything together. Oops. And what's interesting is we know parabolas are kind of, they end up being sort of mirror images as we make them. What we can also say is if I went over from my 0 on the left-hand side, if I went over from this, from the left-hand side 1, I should go up 6. So if I did the same thing here, I go up over 1, I could go up 6, and that is where a point will cross. So then, in all reality, I have 6 points, not just 5 that I could have graphed. So there's our graph of our function. So let's see if everything now ends up to be the same. So we have our zeros, 0, and here is our other 0. So we have our two places where it crosses the x-axis, and now let's go on to what's called our axis of symmetry. So the axis of symmetry is a vertical line that divides a parabola into two symmetrical halves. So it is a vertical line. It's going to go up and down, and it separates things into two symmetrical halves. It passes through the vertex of the parabola. So that's super important to know. It's going to be right where the vertex is, that lowest point or the highest point, the minimum or their maximum. There's two ways that we can find it. We can either take the average of our zeros, or we can use a formula, x is equal to -b over 2a. So let's actually do both. Our average of our zeros, we need to look at our original table. We had 1 0 that happened at a -1, and we had another 0 that happened at 2. So we are going to put those two babies together, or oops, I should go like this, plus 2. When we take the average, we're adding two things together, and then we're dividing by the number of things that we're adding. So we have -1 plus 2, so we'd get 1 over 2. -1 plus 2 is 1, and then divide by 2. So this says our axis of symmetry should be at 1/2. Now let's actually do it with the formula and see if we get the same thing. Oops, sorry. Stop being weird. Sorry. Technical issues. Formula is x is equal to -b over 2a, and if we had our original equation, x is equal to x squared minus x minus 2, then we need to identify our a and our b terms. So our a term is this invisible number 1 out in front of this x squared, and our b term is a -1 in front of that x. So if we were to put that into this equation, we have -1 over 2 times 1. Our b is a -1 and our a is a +1. So then we can actually do some math. We have a negative times a negative, or a negative, so we can turn that into positive. So we have 1 over 2 times 1 is 2. So x equals 1/2, exactly what we had before. Now if we go back to our original equation, if we go back to our graph right here, we can say it's going to cross at 1/2. There is our axis of symmetry. So there we go. Axis of symmetry, which is cool. It's all set and ready to go. Labeled that. We have our zeros labeled. We have our axis of symmetry labeled. And now our last little bit of anatomy that we can look at is what's called our vertex. And we've said it a few times. We've already worked with it in section 9.1. But let's actually understand what is happening with this thing. So finding the vertex of a parabola, we can go through 3 steps to be able to find the vertex. This is the minimum or the maximum of our parabola. Step 1, to find the x-coordinate of the vertex, you need to find the axis of symmetry using, this should say, the zeros of the formula. So we find the x-coordinate using the axis of symmetry. And we can either use the zeros or the formula to do that. Step 2, find the corresponding y-coordinate, because a vertex is a single point. It's going to have an x and y. Substitute the x-coordinate into the vertex of the function. And then lastly, write the vertex as an ordered pair. So for our equation that we have here, y is equal to x squared minus x minus 2, we found that the axis of symmetry, which we've already done, is equal to x, or x equals 2½ And then after that, we need to put this information right here into this equation for all of our x's. So if we had y is equal to 1/2 squared minus 1/2 minus 2, we could then do a little bit of math and figure that out. So let's do that. Let's move this up so we can. So we're on essentially step 2. This is step 2. This was step 1, number 1. This is number 2. So y squared is, or half squared is equal to 1/4. We're squaring the 1, which is 1, and 2, which is 4, minus 1/2 minus 2. And now 1/4 minus 1/2, we would have y is equal to negative 1/4 if we did that, minus 2. So we now have minus, or negative 2 and a quarter for our y. Our step number 3, here we go, right here, is simply writing our x and our y as an ordered pair. So we have 1/2, negative 2 1/4 as our x and y coordinates. So let's see if this makes sense for our equation. We need to see a vertex at 1/2 and negative 2 1/4. And it looks like, can't see exactly, but we're definitely at 1/2, which is awesome, on the x-axis. And we're at 1, 2, and a little bit more. So vertex, our vertex is at 1/2 and negative 2 1/4. So that is the last little step we need to do for section 9.2. I hope this helps, and I hope you can use this to make up any homework that you have missed. Thank you.